So this is one of the pre's from 2015. It's question 7. And I'm just going to go through the calculation parts of it, explaining what's going on. So what we have is a mass at the end of a spring is a system that, the next one. The spring of a mountain bike is compressed vertically by 5 mils when an 80 kg person sits on it. Cyclist rides the bike over a bump on the track and then it oscillates up and down. That's simple harmonic motion. Using the formula, get K, find the period and the number of oscillations given the mass of the frame of the bike and the cyclist. All right, so here's what's happening. We have a spring there on the left. Somebody sits on it and it compresses by 5 millimeters. Now the person that sits on it is 80 kgs. So that means there's a weight going to be done of 80 by 9.8. And that spring is trying to go back to its original position. So there'll be a restoring force acting up. And the weight and the restoring force are equal because when the person sits on it, the person stays at rest. So it's in equilibrium. And that's why I have weight is equal to the restoring force there. Weight is mg. Restoring force is given by minus ks, but we already know they're in opposite directions. So I don't need to put in the minus because I am saying they're equal but opposite by putting them in that form. Divide under for the k and you get the k value. There's 156,800, I think. Now, the next part, to find the period of the oscillation and the number of oscillations, I'm going to derive something, and it's every system that obeys Hooke's law can execute simple harmonic motion. And there's a formula that pops out of it that's in the syllabus that you need to know, and I would suggest remembering as well. So the idea is, if it obeys Hooke's law, it can execute simple harmonic motion. So Hooke's law, first of all, F is equal to minus Ks. If F is equal to MA and we divide under, we get A is minus K over M times S. So that means A is proportional to minus S. So if it obeys Hooke's law, it can execute simple harmonic motion. Right, that's a derivation you need to know, but it's not required here for the question. Nonetheless, I'm showing it to you. Now, if we know that A is equal to minus K over M times S, and the general formula for simple harmonic motion is A is minus omega squared S, it means omega squared is K over M. So omega is root K over M, and that formula is in the log or in the syllabus. So you need to know this. That's the speed of the oscillation up and down is related to the spring constant divided by the mass under a square root sign. Now the reason it's useful here is because we know that the period of oscillation is 2 pi over omega. So T is 2 pi over omega, but omega is root K over M. And when you divide by root K over M, it's the same as having the period is equal to 2 pi root M over K. So that means for the period of oscillation, it's 2 pi, put in the mass of the person and everything else. You're told just above that question that the total mass is 100. Put in the K value and your value will work out there. And look, just for completion, F is the frequency, that's the number of oscillations per second, and that's equal to 1 over the periodic time. So whatever you got for the previous part, get 1 over it.